on this question. So if we have vertical distances, now these are vertical distances of points from a curve, right? Okay? So it's like we've got a curve here. And let's see, one point is 3 units vertically from the curve, either above or below. But let's say, okay, 3 units above. So let's say that's 3 units. So right here is a deviation of 3, right? It's vertical. Okay, and then a deviation of 5. Okay? Well, yeah, deviation of 5, well, it might be 5 low. So that distance is 5, and there's another point, right? And then here's a point that deviates by 2. So let's just say that that's this point here. And then another point that deviates by 7. That's probably too big for 7, but you get the idea, right? Okay? So, first of all, what's the mean vertical distance from a point? Okay, I might even said deviate, but what's the mean vertical deviation or vertical distance from a point, right? So, mean vertical distance is 4.25. I just calculated it here, right? Okay, you might not have been watching, but you didn't need to because you know how we do that. And what it means is, on the average, these things are that far away, right? Okay? Then, not the deviations from the curve, but the deviations from the mean. Are what? Well, I could write this in mathematical terms as an absolute value of like, take the mean minus the number. Actually, you usually do the number minus the mean, so we write it down the way it would traditionally be done. And it also makes sense why we want the absolute value signs, because this is how far, right? If I do the subtraction, of course, I'm going to get a negative number. And as I've explained to some of you, the negative number you get if you did the subtraction would be called the residual. A deviation is the absolute value of a residual. And a deviation then is how far, because an absolute value is how far. Okay? So then we would have not 1.25, 0.75. Are you watching me? Keep an eye on me. Okay. Then we have 2 minus 4.25. Absolute value, and that's 2.25. And we have absolute value of 7 minus 4.25, which is 2.75. Right? Okay? So the squared deviations, because we want the mean of the squared deviations. Okay? Well, first we get the squared deviations. Or what? You square 1.25 and you get, that's 5/4, it's going to be 25/16, which is 1.565, I think. Okay? 3/4 squared is 9/16, which is 0.565, I think. 2.25 squared is 9/4 squared, which is 81/16, which is 5 1/16, which is 5.0625. That should be 5625. If I'm doing it right, it's getting late in the day. And 2.75 would be 11/16, 110, I'm sorry, 121/16, which is 6 and too many 16ths. 112. 7 times 16 is 100. Yeah, okay. So it's, got too many numbers in my head. 6.9375, I kind of think. You can check my numbers on those, okay? You understand what I did, right? So I squared those. Well, the sum of the squared deviations is what I get when I add these up, right? Okay? So, you know, that's about 7, that's about 5, that's about 14. That's not much, but these two add up to about 2, so it's about 16. So the mean squared deviation is about 16 over 4, which is 4, right? And the square root of that would be 2. Okay? So I kind of think that's what the problem's asking. I haven't looked at the problem. But that's how you deconstruct the problem. You ask the question, what's a deviation? Well, to get a deviation, you got to have a mean. Then you subtract everything from that mean, absolute value of, subtract the mean from every number, get your deviations, square them, do the sum of the squared deviations, then you do the mean squared deviation, and take the square root of that, right? That's called a standard deviation. Okay? Make sense? Now that's much related to what we do with curves, but I kind of jumbled a little something about that, so I don't want to try to develop it right now. We'll talk about it next time. But I will say that what we're trying to do is we're trying to, if you have a bunch of points and you're trying to fit a smooth curve, you try to find the smooth curve that minimizes the squared deviations, the total squared deviation, okay? Concept you can think about a little bit, but we'll be talking more about it next week. We want to get you used to just the basic terminology, basic operations here, okay? Okay.